Good morning, friends. In chapter 14 Semiconductor Electronics, we are going to discuss about the logic gate. We discussed about the NOT gate, OR gate and also the AND gate. After that, we are going to start our discussion about the NAND and NOR gate. Right? Okay, these two gates are not the basic gate. They are prepared by the combination of AND plus NOT, we obtain the NAND gate. OR plus NOT, we obtain the NOR gate. Today we are going to discuss about the NAND and also the NOR gate. How it is prepared and what is the truth table and function and Boolean equation and what is the symbol for NAND gate and NOR gate. Before starting our discussion about the NAND gate and OR gate, just revise about the AND gate. AND gate has the two inputs, one output. Right? And what is the characteristic or the function of the AND gate? Function of the AND gate is that there is the truth table of AND gate up to this. In AND gate, we obtain the output is 1 if all inputs are 1, otherwise 0. Because in AND gate, the Boolean equation y is equal to a dot b. Characteristic is that output is 1 if all inputs are 1, otherwise 0. Or in other words, if any one output or if any one inputs or all inputs are 0, we obtain the output is 0. The symbol of AND gate is this, but here bubble is not present. Without the bubble, there is the symbol of AND gate, and Boolean equation is y is equal to a dot b. Here dot is operator of AND gate. There is not the sign of the multiplication. Clear this? Okay. Again we revise it. What is the truth table? In truth table, there is the truth table of AND gate. If both inputs are 0, output is 0. If A is 0, B is 1, output is 0. If A is 1, B is 0, output is 0. And if both inputs are 1, output is 1. Therefore, the output is 1 if and only if all inputs are 1 for AND gate. Or in other words, output is 0 if all inputs or any one inputs is 0. That is the characteristic of AND gate. Clear? Okay, now what about the OR gate? OR gate has also the two inputs, one output. Right? Boolean equation is y is equal to a plus b. That is read as y equal to a or b. Clear? Now the truth table of OR gate is shown here. If the both inputs are 0, we get the output is 0. Otherwise 1. That means the A is 0, B is 1, output is 1. A is 1, B is 0, output is 1. If both are 1, so output is also 1. So from this table we can say that what is the characteristic of OR gate. If all inputs are 1, if any one input or the all inputs are 1, output is 1. Again, the function of OR gate is that if any one or all inputs are 1, output is 1. Or in other words, if all inputs are 0, output is 0. While in AND gate, if all inputs are 1, output is 1. While in OR gate, if all inputs are 0, output is 0. That means the 0, 0, 0. For OR gate, 1, 1, 1. That is for AND gate. What is the symbol of OR gate? So without bubble, there is the symbol of OR gate, and Boolean equation is y is equal to a plus b. Okay. After the revision of the AND and OR gate, we start our discussion about the NAND and NOR gate. Because the NAND gate and NOR gate are prepared by the combination of the AND plus NOT, we obtain the NAND gate. OR plus NOT, we obtain the NOR gate. That means the output of AND gate is given as the input of a NOT gate. Now what is the NOT gate? NOT gate is the inverter gate. Whatever the input given, inverse input we obtain. As we give the input as 0, we obtain the output 1. As we give the 1 as an input, we obtain the output 0. Therefore, that is known as the inverter gate. The symbol of NOT gate is this triangle with bubble. That is the symbol of NOT gate. Okay. Now, NAND gate and NOR gate are easy, but we had to knowledge about the AND and OR gate. Okay. Now, how we prepare the NAND gate? First, the question is that what is the NAND gate? Write its symbol, truth table, function, and Boolean equation of NAND gate. Okay. NAND gate is prepared or constructed by the combination of AND and NOR gate. Again, the NAND gate is constructed by combination of AND gate and NOR gate. The output of AND gate is given as an input to the NOR gate. Again, what is the output of AND gate? Is given as an input to the NOR gate. Like to this way, the output of AND gate is supplied as the input of NOR gate. So this combination of both gate AND and NOT that gives the NAND gate. That means the AND plus NOT is equal to NAND gate. Again, the combination of two basic gate AND plus NOT, we obtain the NAND gate. That means the output of AND gate is given as the input of NOT gate. So from this symbolic construction, we can say that what is the output of AND gate? Now there is the inverted by the NOT gate. So Boolean equation for AND gate is y dash is equal to A dot B. That is given as input of NOT gate. Therefore, output of NOT gate is inverted of y dash. Y dash is A dot B. Therefore, y is equal to A dot B bar. That is the Boolean equation for the NAND gate. That is the Boolean equation for NAND gate. What is the symbol? Symbol of the NAND gate is the symbol of AND gate with bubble. Bubble represents that is the inverted of AND gate. Inverted of AND gate. That means there is the NAND gate, not AND. Again, there is the symbol of AND gate. Now addition with the bubble, so that gives the symbol of NAND gate. Here the inputs are A and B, and output is y is equal to A dot B bar. So that is the symbol. Now NAND gate has the two inputs and one output. Truth table of NAND gate. Here the two input, therefore four different ways we can supply the input. Last we also discussed to mention the order. So in A column, first to 0, then to 1 1. B 0 1 0 1. Now all these four inputs are different. Here, for keep in mind the easily the truth table of the NAND gate. First we prepare the truth table of AND gate, and then there is the inverted that gives the truth table of NAND gate. In AND gate, what is the characteristic? The 1 1 1. That means the output is 1 if all inputs are 1, otherwise 0. Right? Therefore 0 0 0, 0 1 1, 1 0 0, 1 1 1. Or from the Boolean equation, A dot B, 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 1 1. Now this output is given as the input to the NOT gate. Therefore, NOT gate is the inverter gate. So this output is inverted. This output of AND gate is inverted. 0 1 0 1 0 1 1 0. Again, the truth table of the NAND gate. First we discuss this part of AND gate only. A and B are the input, Y dash is the output. Therefore, preparation of the truth table is this. A, B are the input. For different manner, we can add the combination of input 0, 0, 0, 1, 1, 0, 1, 1. What is the characteristic of AND gate? Output is 1 if all inputs are 1, otherwise 0. So here 1, 1, therefore 1, all other output of AND gate are 0. Now this output is given as an input to the NOT gate. Therefore there is the inverted because there is the NOT gate. Therefore 0 inverted by 1, 0 inverted to 1, 0, 1, 1, 0. So there is the truth table of NAND gate, there is the output of AND gate. So as we add the combined output of AND and output of NAND gate, so it becomes the very easy. Now what is the function? So what is the different output? Different output is this 0, otherwise 1. So that is the different. So that is the characteristic of NAND gate. So how we describe, forget this part, how we describe the function of the NAND gate? Output is 1 if any one or the all inputs are 0. Output is 1 if any one or all inputs are 0. Therefore the function is when any input or the all inputs are 0. Any inputs or all inputs are 0, output is 1. Or in other words, if all inputs are 1, output is 0. If all inputs are 1, output is 0. So that is the function of the working of NAND gate. Again we repeat it. Yeah, output of a NAND gate is 1, 1, 1, 0. Two different manner we can describe the function of NAND gate. One, first on the base of the output 1. Output 1 is obtained if all inputs are 0 or the any one inputs are 1. Or any one inputs are 0. So we can add that when any input or all inputs are 0. So output is 1. Or in other method, output is 0 if all inputs are 1. That means if all inputs are 1, then output is 0. What is the Boolean equation for the NAND gate? So y is equal to a dot b bar. A dot b is the Boolean equation for the AND gate. Now bar of this a dot b, so that gives the Boolean equation for NAND gate. It is read as the y equal to not a and b. Y equal to not a and b. Because the not represents the AND operator. This bar represents the not operator. Therefore, not a and b. Not a and b. That is the Boolean equation. Y equal to not a and b. Now, NAND gate is also called a universal gate. Because by using this gate, we can realize the other basic gates like OR, and NOT gate. Therefore, that is known as NAND and NOR gate are known as the universal gate, while the AND, OR, and NOT are known as the basic gate. So sometimes the objective question may be asked, generally in good set, which of the following are the universal gate? So none or no are the universal gate. Clear this? Okay. Now in NAND gate, there is a combination of AND plus NOT. Output of AND gate is given as the input of a NOT gate. Like to this way, output of AND gate is given as an input of NOT gate. We obtain this combination is act as a NAND gate. Boolean equation of the AND gate y dash is equal to a dot b. That is inverted by the NOT gate. Therefore, the Boolean equation for the NAND gate is y is equal to a dot b. Symbol of NAND gate is the same as the AND gate, but here with bubble. So in symbol, that is necessary to mention the a and b are the input, and output y is equal to a dot b bar. not only y, we have to also mention with Boolean equation. Now it has the 2 input and 1 output. Truth table for NAND gate is this. Truth table of AND gate, and this output of the AND gate is inverted by the NOT gate. So for AND gate, characteristic is that output is 1 if all inputs are 1, otherwise 0. This output of AND gate is inverted due to the NOT gate. Therefore 0, 1, 0, 1, 0, 1, 1, 0. So there is the final output of a NAND gate. Boolean equation of the NAND gate is y is equal to a dot b bar. What is the function? Here the different output is this, 0. 0 we obtain if all inputs are 1. So function is if all inputs are 1, output is 0. Or from this remaining 3, if any one inputs or all inputs are 0, output is 1. NAND gate is called the universal gate. Boolean equation y is equal to a dot b bar. It is read as y equal to not a and b. Not a and b. Clear this? Okay. Now similar as the NOR gate. So what is the NOR gate? Yeah, its symbol, truth table, function and Boolean equation. NOR gate is constructed by combination of OR gate and NOT gate. That means same as the output of OR gate is given as an input to the NOT gate. The output of OR gate is given as an input to the NOT gate, like this way. OR plus NOT, this combination gives the NOR gate. Output of OR gate is given as the input of NOT gate. Therefore, there is the up to this y dash is equal to a plus b. There is the OR gate. So output of OR gate is inverted by the NOT gate. So there is the output of NOR gate. Right. Now the symbol of a NOR gate is the OR gate with bubble. OR gate with bubble. So there is the symbol of OR gate. Now addition is the bubble. So that represents the symbol of NOR gate. Now symbol AB inputs. Now output of OR gate y is equal to a plus b. But due to the NOT gate, that is the a plus b bar. That is the Boolean equation for NOR gate. How we prepare the truth table? Truth table of the NOR gate is, first we prepare the truth table of OR gate. Last column we skip. Therefore, A, B are the input. Here the two inputs. Therefore, 4 different ways we can supply the input. Now, what is the characteristic of the OR gate? If all inputs are 0, output is 0, otherwise 1. So here, OR gate. If all inputs are 0, output is 0, otherwise 1. Or in other words, if any one inputs or all inputs are 1, output is 1 for OR gate. At present, we are discussing about the truth table for OR gate, not NOR. Keep in mind that. Here, forget this part. For OR gate, if all inputs are 0, output is 0. Or in other words, if any one or all inputs are 1, output is 1. So this output of OR gate is given as an input to the NOT gate. So that is the inverted. Due to the NOT gate. What is the 0 is given? Here we obtain the 1. Here 1 is given, we obtain the 0. 1, again 0, 1, again 0, 1, again 0. So last column is the output of a NOR gate that is inverted the output of OR gate by NOT gate. So 0, 1, 1, 0, 1, 0, 1, 0. So from the output of NOR gate, what is the different output? So first is the different output for the NOR gate. Therefore, there is the characteristic of NOR gate. So we can describe the function of NOR gate from this characteristic. If all inputs are 1, if all inputs are 0, output is 1. Function of NOR gate is if all inputs are 0, output is 1. Again, if all inputs are 0, output is 1. From the remaining output 0, we can also describe the function. In which case we obtain the 0. If any one inputs are 1 or all inputs are 1, we obtain the output is 0. For that purpose, if any one or all inputs are 1, then output is 0. Other method to describe the function of a NOR gate is if any one or all inputs are 1, output is 0. Yeah? So two different manners we can describe the function. One is if all inputs are 0, output is 1. Second is if any one inputs are 1 or any one or all inputs are 1, output is 0. Boolean equation of NOR gate is y is equal to a plus b bar. A plus b is the Boolean equation of OR gate. There is the inverted by the NOT. Therefore, bar symbol represents the NOT gate. So a plus b bar, y is equal to a plus b bar, and this equation is read as y is equal to not a or b. Y equal to not a or b. Clear? NOR gate is also called the universal gate, same as for the NAND gate. So we can realize the basic gates like the OR gate, AND gate, and also the NOT gate by using of the NOR gate. Again, how we obtain the NOR gate? By the combination of OR and NOT gate. OR plus NOT, that gives the NOR gate. It means the output of OR gate is given as an input of NOT gate. Again, the output of OR gate is given as an input to the NOT gate. So like this way. To prepare the truth table, we divide in two parts. First, we prepare the truth table for AND gate, and then that is given to the NOT gate. So that is the inverted input obtained. That is the output of NOR gate. For that purpose, first three columns of this table that represents the truth table for OR gate. Here the two inputs, four different ways we can supply the input: A 0 0 1 1, B 0 1 0 1. Characteristic of OR gate is that if all inputs are 0, output is 0, otherwise 1. Therefore 0 0 0, 0 1 1, 1 0 1, 1 1 1. This output is given to the input to the NOT gate. So we obtain the inverted output of input. So 0 inverted to the 1, 1 inverted to the 0, 1 inverted to 0, 1 inverted to 0. So finally, there is the truth table for the NOR gate. So it is easy to keep in mind that we have to also add down the output of OR gate here, and here the output of AND gate, to prepare the truth table of null and NOR gate. Now what is the Boolean equation? Boolean equation of OR gate is y dash is equal to a plus b. This Boolean equation is inverted. That means with bar. So that gives the Boolean equation of the NOR gate. So y is equal to a plus b bar. So what is the function? That is the different output for the NOR gate. One is different if all inputs are 0. So function of the NOR gate, if all inputs are 0, then output is 1. Or the method is to describe the function: if any one or all inputs are 1, output is 0. Again, if all inputs are 0, output is 1. Or if any one or all inputs are 1, output is 0. So that is the function of NOR gate. Now, what is the Boolean equation? Boolean equation y is equal to a plus b bar. That is it as y equal to not a or b. NOR is an also universal gate. Clear? So there is the discussion about the NAND gate and NOR gate. Clear? So after the discussion of this, we start the numerical on the base of the logic gate. So keep in mind that generally in objective type question, different combination of the logic gates are given. We have to prepare the truth table or to also write down the Boolean equation for that. So for that purpose, it is necessary to know the function of particular gate, like to the AND gate, OR gate, NAND and NOR gate. Or what is the characteristic of that? Characteristic of OR gate is that 0, 0, 0. Right? Characteristic of AND gate is 1, 1, 1. Now, yes, there is the NAND gate, so 1, 1, 1. That is the AND gate, then 0. So that is the characteristic of NAND gate. There is the AND gate is 1, 1, 1. That is the input A, B, that is the Y. And for NAND gate, Y is 0. 1, 1, 1, 0. While for NOR gate A, B, Y dash and 1. 0, 0, 1. Sorry, 0, 0, 0. So that is the inverted, that is the characteristic. That is the characteristic for NOR gate 0, 0, 1 and for AND gate 1, 1, 0. So keep in mind these sentences so we can solve the any numerical depends on the logic gate. Clear? Okay, here this chapter is completed. Now we start our discussion about the numerical.